Hi friends, here I am going to present some topics on paper 7 of Analysis 2 and Algebra 4 of Davangere University 6th semester Mathematics. First, we know complex numbers. So what are complex numbers? So complex numbers are the extension of real numbers. So after we have already studied about the natural numbers, integers, rational numbers, real numbers. Now we have to study complex numbers. So complex numbers are the extension of real numbers, and also because of square root of -1, square root of -2 and square root of negatives. So we cannot write the definite values of square root of negatives. So because of square root of negatives, we take that square root of -1 as an imaginary unit that is denoted by I. So using that I symbol, we express the numbers in the form of x plus iy. Here x and y are real numbers. So this representation is called complex numbers. So we can write complex numbers in two different forms. First one is Cartesian form. Another one is polar form. So in Cartesian form, we write the complex number z is equal to x plus iy. Here x is called real part of complex number. It is denoted by rez, and y is called imaginary part of complex number. It is denoted by imz. So let us we know how we write the complex number in polar forms. So in polar forms, we have to use the polar coordinates to write complex number. So the polar coordinates are r and theta. We write the complex number in polar form as z is equal to r into cos theta plus I sin theta, where r is called the modulus of complex number. It is denoted by mod z, and theta is called amplitude of complex number. It is denoted by ampz, or argument. It is denoted by argz. So now we have to establish a relationship between Cartesian form and polar forms. So as we know, Cartesian form of complex number is x plus iy, and in polar form it is r into cos theta plus I sin theta. So by equating x and y, so corresponding real and imaginary parts, x is equal to r cos theta, so y is equal to r sin theta. And by squaring and adding, we get r square is equal to x square plus y square, or r is equal to square root of x square plus y square. So which is the modulus. Similarly, by dividing y by x, we get tan theta is equal to y by x, or theta is equal to tan inverse of y by x. So that is amplitude of complex number. So next we have to represent the complex number by means of geometry. So geometrical representation of complex numbers. So this is also called as Argand diagram or Argand plane. So any complex numbers can be represented by means of points on a plane. So this plane is called Argand plane or Argand diagram. So here we see that the complex number p of x plus iy represented by the point p of x comma y in the plane, that is in the xy plane. This is a rectangular coordinate system. So here the horizontal line x dash o x is called real axis, that is x axis, and vertical line y o y dash is called imaginary axis. Here also we can establish relationship between Cartesian form and polar forms by taking this length OP is equal to r, and using the Cartesian coordinates x and y. So this OP makes an angle theta with x-axis. So this is a right angle triangle. Using this right angle triangle, we write x is equal to r cos theta and y is equal to r sin theta. And also by squaring and adding, we get mod z is equal to square root of x square plus y square, that is r, and theta is equal to tan inverse of y by x, that is amplitude of z. So let us we know some operations on complex numbers. So the operations similar to the real numbers. Here also we have some operations, that is like addition, subtraction, multiplication, and division of real numbers. So here also we have to do the same operations on complex numbers and also some different operations. So let us see one by one. Equality of two complex numbers. So two complex numbers z1 is equal to a plus ib and z2 is equal to c plus id are equal if and only if the real and imaginary parts are separately equal. That is z1 is equal to z2 implies a is equal to c, that is real parts, and b is equal to d, imaginary parts. Next, the operation is addition of complex numbers. So if any two complex numbers can be added, we can find sum of any two complex numbers by adding the corresponding real parts and imaginary parts separately. So here we can see that z1 plus z2 is equal to a plus c, that is real parts sum, plus I into b plus d, sum of the imaginary parts. So third operation is multiplication of complex numbers. So any two complex numbers can be multiplied as usual. As in the case of real numbers, here also we can multiply two complex numbers, that is z1 z2 is equal to a plus ib into c plus id. So we have to multiply a with c plus id and ib with c plus id. So we get ac minus bd plus I into bc plus ad. So which is again a complex number. Next we have to find the conjugate of complex number. So this property is not comes in real numbers. So it is only in complex numbers. So if z is equal to x plus iy is any complex number, then x minus iy. So we change the sign of imaginary part. So here we have plus, here it is minus. So this x minus iy denoted by z bar is the conjugate of z is equal to x plus iy. So conjugate of complex number is nothing but changing the sign of imaginary part. So with this conjugate, here we have seen some properties. If z is equal to z bar, that is complex number is equal to its conjugate. The conjugate is equal to its complex number itself. Then the complex number is purely real. So the sum of complex number and its conjugate, so that is also real number 2x. And difference, that is subtraction of conjugate from the complex number, z minus z bar is equal to 2iy. So which is purely imaginary, there is no real part. Z into z bar, the product of complex number and its conjugate, so that is x square plus y square. So x plus iy into x minus iy, a plus b into a minus b, a square minus b square, x square minus I square y square. I square is equal to minus 1, so it is becomes plus 1. X square plus y square, so which is a real number. So the product of complex number and its conjugate is always real number. And division of complex number by its conjugate, so that is x plus iy divided by x minus iy. So on rationalizing, that is we have to multiply both numerator and the denominator by the conjugate of denominator, that is x plus iy. So x plus iy, we multiply both numerator and denominator. So in numerator it is x plus iy whole square, in denominator x plus iy into x minus iy, that is x square plus y square. So on multiplication we get x square minus y square plus 2i xy. So on splitting we get x square minus y square by x square plus y square plus I into 2xy by x square plus y square, which is again a complex number. So in finally we have to see the division of complex number. So any two complex numbers can be divided by multiplying its conjugate of denominator. If z1 is equal to a plus ib and z2 is equal to c plus id, then the division of z1 by z2 is equal to a plus ib by c plus id. So here we have to multiply. So in complex numbers, division means you have to multiply both numerator and denominator by the conjugate of denominator. So the conjugate of c plus id is c minus id. So you have to multiply c minus id to both numerator and denominator, that is a plus ib into c minus id divided by c plus id into c minus id. So we get in the denominator it is c square plus d square. In numerator we get ac plus bd plus I into BC minus CD. So the division of any two complex number is again a complex number. So these are some operations on complex numbers. Thank you.